Hi guys, welcome back to my channel. So today, as we know from the title, we are gonna learn amorphous cell module available in the Material Studio. So in the previous video, you have learned about the polymers. So what's next? It's about after building polymer, you should utilize it. So the next step is morphoscell construction. And in the previous tutorial, you have also learned how to build polymers in the Material Studio. I have already created a project here with the name tutorial 3. I hope you all know by now that how to create a project. If not, you can go and check it out in my previous tutorials. So I will start with building a polymer, very simple polymer I will select. I will choose any available polymer that is already, the monomer is already available in the library of the Material Studio. So I'm gonna choose any carbohydrate, and there are different monomers available. Before that, I want to show you, you can also go to the Material Studio library from the Import tab, and you can click on the structures and you can select any structure of your choice. There are not all other structures that are available, but very well-known structures. You don't have to create it from the scratch. You can just import it. Like there are many repeat units available. Amides, like nylon, don't have to build it. You can just import it. So you can check the Material Studio library always before constructing a structure. Like if you are creating a new structure, that makes sense, you are building it. But there are other platforms also available, like crystallographic data center. You can also import some structures from there. And there are many structures available in the Material Studio library, like the basic ones, some metal oxides, some carbohydrates, some zeolites as well. So you can check, and uh, it saves a lot of time just to import a structure. So I'm gonna select 1,4-beta-glucose because it's a monomer of cellulose nanocrystals. So I'm just selecting it, um, this one, repeat unit. And technicity, I already told you that why I'm selecting isotactic in my previous tutorial. And the chain length. 8 repeat units are also good enough to study CNC, but I'm selecting 10 here. I'm just building a chain with heterotoll. Yeah. So you already know all these options. So here we are. I'm just gonna make it big. So I'm gonna change the style first so that you can see the atoms. So we have carbon, hydrogen, and oxygen here. And this is a chain. You can see the chemical formula here, that how many atoms are present here. And you can also check the repeat unit name here. And before proceeding further, what is my practice? I always do geometry optimization. It's better to have optimized structures before proceeding further. So I'm gonna do geometry optimization, and I'm selecting compass. I have already told that every compound, every molecule is suitable for swale. So this one compass is the suitable one. And I'm selecting geometry optimization here, and yeah, smart algorithm. So I'm gonna run it, and while it is running, I'm gonna show you about amorphous cell. So why I'm using that amorphous cell module is to like have a bulk system. We know that polymers are very long chains in reality. So I have to build a bulk system of the polymer. So I'm gonna, this has already been optimized. So I'm gonna make a bulk system of this polymer. Let me check the graphs first. Okay, we're just gonna proceed for the sake of this tutorial. So I'm gonna select calculations. The task will be the construction because I haven't constructed anything yet. If I have already a simulation box, I can also use packing and confined layers. And for the energy calculation, I'm gonna use compass, force field, and job control, obviously my computer. And for the density, we always consider density about 80%, 70% of the actual density. So I'm gonna selecting here 0.95. You can select the according to the original density. Like the basic purpose of this to have to give enough volume to the system. So if we have lesser density, like 70% of the actual density, like for example, if we have actual density of 1 and we want to take 70%, so we will keep 0.7 here. So we always keep less density to give enough volume. We all know that mass to volume ratio is the density. So lesser the density, more volume we are giving to that system to adjust perfectly. So the temperature I'm gonna use 290. I'm always prefer on the first calculation to use room temperature calculation, room temperature. So I'm gonna load this here. You can load according to your choice as many molecules you can, and you can also add any other molecule. You can also make a composite structure with different molecules as well. So I'm gonna select this, the weight percentage here. Also you can also adjust this thing. The force field always compass for this system. So I'm gonna run this, and after running this, you will see that we have got a simulation box. So this will take a while, I think so, because I have added a more loading. If I'm okay, I have already got it. You see, I have got a simulation box with two CNC chains. If I am gonna, if we proceed with the foresight dynamics here, and I have already selected NVIDIA, okay. I'm just gonna perform it for 15 picoseconds, so very less time. I'm just gonna perform it for just so that I have a quick result, just the thing I wanna show you here that I can show you on time. So an animation will be generated that how this has been constructed. This is force dynamics all know that we perform it for to achieve equilibrium, and the settings of thermodynamics I have selected is NPT. I can show you again that in which the number of molecules, pressure and temperature is constant. We can also select NVT, NPH, NVE according to the requirement. The temperature always room temperature I'm selecting. So the thermostat that I am selecting here NPT. So that means that pressure and temperature should also be controlled. I have already, I think so, mentioned some of my tutorials. So you can also get a detail from the force dynamics tutorial as well. So thermostat is to control the temperature because we are saying that we are selecting ensemble in which temperature is constant. So um, after that, we start getting results, and you can also see the density value in the graph, that it is actually reaching the actual density value. The initial density we have given is 0.95, and it is actually going towards the actual density value. You can also get the value of cell length, and you can also observe that how it is decreasing with time. If you compare these two things, that as the density, okay, we have already got the results. So what I'm gonna show you here is that animation that you obtain from the force dynamics. Just to please. Okay, what's the status? The final density we are getting is 1.35 gram per centimeter cube. So I think that's all. You know that how to use a amorphous cell and how to construct it. So we have already got it. And I can also show you someday that how to do packing, confined layer, and composite. Like the application of this, you can use this module to study the gas transport properties as well. So I hope it's beneficial for you. Allahumma barik.